Senior at Urban High School, and this is my main project for Bluestamp this year. It is a box with a musical lock, which means that it is a box that will only unlock when you play the correct melody. I had to go through several design iterations in order to finally get this working project, mainly because the original design files that I found online from the original creator of this project are incomplete and list components that don't exist anymore. For example, the power supply, or the voltage regulator that I got to originally supply the VCC to my ATmega only outputted 3.3 volts, and I needed 5 volts to run the ATmega at 16 megahertz, which is what I need in order to get a reasonable input resolution from the microphone in order to detect melodies. So from the voltage regulator to several other components, I had to go online and figure out which components I actually needed instead of the ones that he listed. But once I had everything in order, then I could start building. And the first step then was to come up with an algorithm that would find a specific frequency in the signal. And the algorithm I chose is called a Goertzel algorithm, or Goertzel filter, which computes efficiently one component of a discrete Fourier transform, or in simple terms, that's basically the magnitude of a specific frequency in an audio signal. And to test this algorithm, I connected my ATmega to the function generator we have here, which originally didn't work very well because it turned out that the sampling rate I chose for the analog to digital converter connected to the microphone, or in this case the function generator, was too low. So the frequencies that I was looking for were above the maximum detectable frequency. So it didn't. So the algorithm responded erratically to the signal. So I changed that, and then it worked. And then the next step was to get the algorithm to respond to multiple frequencies in series, and also to get it to control a servo. So the next thing I worked on was getting the algorithm to control a servo motor. And there were several problems that I came across when attempting to do this, mainly that whenever I connected a servo which was powerful enough to control the lock, it drew too much current from the ATmega, which set off the brownout detector and reset the system. So I eventually solved this problem by adding a decoupling capacitor between my main power supply and the ground, so that when the servo drew current away from the ATmega, the capacitor would ensure that the overall flow of current to the ATmega never dropped low enough to set off the brownout detector. So once I had the servo working, then the next step was to connect that to the melody detection. And once I had the microphone in and the servo connected, I began testing a full melody. And the original melody I chose was from Close Encounters of the Third Kind, which ended up not working very well because the notes in the melody were too harmonically related. In other words, there were overtones that overlapped in the notes, which was confusing the algorithm. So I ended up choosing something else, Greensleeves. So when I switched the melody from Close Encounters of the Third Kind to Greensleeves, then the algorithm worked, and the lock mechanism was complete, which I can demonstrate now. So, as you can see, the lock right now is set and the box won't open, but if I play the correct melody, then it should unlock. As you can see here, the box is locked and won't open, but if I play the correct melody, then the box opens.